Hey everyone, welcome back. Alright, so what we've got here today is we're going to be talking about equations and slope. We've learned that when we make equations that we can draw straight lines. For example, here's a straight line. There's an equation that goes with this, but what we're going to talk about today is the different parts of a line. First we want to talk about the x-intercept. That is where the line crosses the x-axis. It also occurs when y equals 0. One of the best ways to remember that is that here's y equals 2, here's y equals 1, and here's y equals 0, right on the x-axis. The next concept we want to talk about is the y-intercept, and that's when the line crosses the y-axis. And just concurrently, this also occurs when x equals 0. Once again, x equals 2, x equals 1, x equals 0, right on the line. Linear equations can be written in a form called y equals mx plus b, and we call this the slope-intercept form, and we're going to learn why that works. Okay, so here's an equation. We know it's going to make a straight line. What we learned before is that we could simply pick values for x, plug them in, and figure out what the values for y are. When we plot those points, they form a straight line. All right, so if I have these 2 points, I know I can figure out the slope of my graph. We learned that previously also. We pick a point to be point 1, a point to be point 2. That gets us x1, y1, x2, y2. We write the formula. We plug the numbers in very carefully in the right spots. And then we do our arithmetic. We end up getting x equals -2. Well, there's something that's going to be kind of interesting there. Where else did you see a -2 before we saw it down here inside the red box? That's right up here. And so what I want you guys to realize is that the slope in slope y-intercept form, the slope is the number that comes before the variable x, or what's known as the coefficient of x, when y is isolated. So does anyone know what the slope of this line would be? Well, without graphing it or without having to do 2 points, I know instantaneously that the slope is going to be 5. All right, but what if I have an equation like this? The most popular wrong answer is people will tell me 4. But remember one of the caveats. Y must be isolated. So how do we isolate y? We go back and we remember our basic algebra steps. We use the addition property of equality to add -4 to both 4x to both sides of an equation. When I do that, I get y equals -4x plus 15. And what do you know? I now can figure out my slope. It would be -4. Once again, when solving these problems, y is not isolated, so we have to get y isolated. And this is just a standard 2-step equation. So I go -7x minus 7x. Then I divide by -2 and divide by -2. One thing to remember is that when I'm dividing both -7x and 12 by -2, I need to divide them both by -2. -7 divided by -2 gets me +7/2, and 6 divided by -2 gets me -6. What's my slope? 7/2. Once again, I didn't have to do any graphing, and I didn't have to do any of the slope formula to figure this out. So let's go back to our problem. We all know that this has a slope of -2, but let's go back to our line. There are 2 points. There's our line. Where does this line cross the y-axis? It crosses right here. What do you notice? What do you notice? Yep, that's true. The number that's being added on here in slope y-intercept form tells me that this line crosses the y-axis. Its y-intercept is 4. So in this situation, what would the slope be and what would the y-intercept be? Well, slope would be -5. It's the coefficient in front of the x, and the y-intercept would be 6. What about this one? Well, the y is not by itself. Therefore, I need to isolate the variable. I go -10x minus 10x. Divide by 5, divide by 5. Remember to divide the 5 by both the -10x and the 15. And I get y equals 2x, -2x plus 3. What's the slope? -2. What's the y-intercept? 3. Pretty easy once you isolate the y. This is a good one. What would the slope be? Give you a minute to think about it, and then I'll come back. All right, the slope is going to be -1. Because there's one x. We don't actually write the coefficient 1, we just assume that if there's only one x, everyone knows that there's one x. Where would this line cross the y-axis? Give you a second. Okay, I'm back. It crosses at 0. Notice there's nothing being added on here to this x, so this would be negative x plus 0, and that's why it crosses the y-axis at 0. If we want to do this one, once again, we just have to do our two-step algebra. Minus plus 7x, divide by 5, divide by 5. Y is by itself, slope is 7/5, y-intercept 2. All right, so why do we learn this stuff? That's a good question. Oops. All right, so we have our slope-intercept equation. Y equals mx plus b. M stands for the slope. B stands for where the line crosses the y-axis, or what's known as the y-intercept. So why do we learn this stuff? Good question. Well, actually, it's a shortcut. It will help you in graphing the equations. What we learned earlier was if I want to be able to graph this equation, I can always pick an x and get a y, pick an x and get a y, pick an x and get a y. But what if I just realize that where is this line going to cross the y-axis? It's going to cross at -2. So I can put a point at -2. What's this line's slope? It's 3, or 3 over 1. So that means I just go rise 3, run 1, and I get my new point. And there's the line. Notice, had I picked 1 for x, 3 times 1 is 3, plus -2 is 1. That is the point we would have, 1, 1. And notice we can continue this pattern for a while. Rise 3, run 1, and we would get a new point. Makes it nice and easy. Where's this line going to cross the y-axis? -1. What are the directions to the next point? What's the slope? 3 over 4. Rise 3, run 4. Voila. And this one, where are we going to cross the y-axis? You guessed it, 2. What's the slope? 1, because there's 1x. Rise 1, run 1. And we get our line. Once again, notice you could repeat this for a while. Rise 1, run 1, rise 1, run 1. We always end up right back on the line. Okay, I have 3 where I'm going to be crossing the y-axis, and then my slope is -5/2. Down 5 over 2. And I get it. Notice I went down 5 because -5 goes down the y-axis. What if I have this one? Uh-oh, the y is not by itself. Good thing we know algebra. -4x minus 4x. Y equals -4x plus 5. Y-intercept is at 5. Slope is -4. Down 4 over 1. Goodness gracious, what if they gave us this one? Well, isolate y. Plus 4x plus 4x. Divide by 5, divide by 5. And crosses the y-axis at 2, and the slope is 4/5. Rise 4, run 5. And there you go. All right, that's the lesson. Hopefully this shortcut does help save you time in graphing linear equations. If you got any questions, make sure to let me know. Thanks, everybody.